Now, as we have done in previous sections, we're going to use our understanding of geometric and trigonometric concepts to help solve problems. And this is a very fun problem, and there's an animated graphic that accompanies this problem that you can explore that hopefully allows you to visualize what is occurring. So this problem reads, the Ferris wheel at Pacific Park on the Santa Monica Pier in California has a diameter of 90 feet. Suppose friends Estefania and Nicole are riding the Ferris wheel when the wheel stops to let on more passengers. So a couple of things to point out now. A Ferris wheel obviously is a circular ride. If you look at the animation, you'll see that. And it has a diameter of 90 feet. So if it's got a diameter of 90 feet, that must mean it has a radius of 45 feet. And that's going to be important because that's going to help us determine these distances. So since the Ferris wheel is a circular ride, I'm going to go ahead and put up a unit circle here. The Ferris wheel replicates a unit circle and vice versa. So we're going to use our unit circle to help us determine these distances. That's the whole idea for this problem. So A says if the car the girls are riding has a central angle of 60 degrees from horizontal when the wheel stops, how high above the pier are the girls? So a couple other things to point out here is this is the horizontal. That's our x-axis. That's what that means, 60 degrees from the horizontal. And another thing is we want to know how high above the pier are the girls. So we're going to assume that the pier is right at the bottom of the Ferris wheel here. So I'm just going to kind of pencil it in like that. So now it says if the car the girls are riding has a central angle of 60 degrees from the horizontal. So 60 degrees is right about here. And of course, this is going to create our special right triangle. This won't be a 30, 60, 90 special right triangle. And since this is now a 30, 60 special right triangle, if this is a unit circle and this is 1 unit in measure, the pattern for these lengths here for this special right 30, 60, 90 special right triangle, this one right here is the one that we're concerned with. This is the square root of 3 over 2. But this isn't 1 unit. This radius is not 1 unit. This hypotenuse is not 1 unit. It's going to be 45 or 45 feet. So we have to multiply this measure by 45 feet. So we have 45 times the square root of 3 over 2. Now that's the measure from here to the x-axis here. We want to know how far they are above the pier, and that's all the way down here. So this length right here is the length of the radius. So I just add another 45 feet. This first measure here, 45 root 3 over 2, that's from the girl's car to the horizontal, or at least to the x-axis, and then from the x-axis all the way down to the pier to the bottom of the Ferris wheel is another 45 feet. So I'm going to call up the calculator, and I'm going to type in 45 times the square root of 3. And don't forget that arrow right there says that the next entry is going to be underneath the radical sign, and we don't want that, so I'm going to move it over like that. Now it's outside it. Divide that by 2, and I'm going to hit enter. And that gives us our 45 root 3 over 2. Now I have these double arrow keys. I use the TI-30 calculator. I have these double arrow keys, and when I hit that, it gives us the approximation of 45 root 3 over 2, which is approximately 38.97 feet. That's this distance right here. I'm going to add another 45 feet to that. So the distance from here all the way down, because we want to find out the distance above the pier, is 83.97 feet. So this is approximately 83.97 feet. So that's what it is for A. And that's the whole point. A lot of these visuals we can see. To try to verbally explain that to you, it's going to be difficult, but hopefully you can visualize it. This is our Ferris wheel. Here is the girl's car, and then we want to know how high they are above the pier at that time. So let's try B. If the car the girls are riding has a central angle of 120 degrees from horizontal when the wheel stops, how high above the pier are the girls? Well, 120 degrees, that's over here. That's going to be the same height as it was when it was at 60 degrees in the previous problem, except we're just on the other side of the vertical axes here. So the height isn't going to change. It's going to be the same as it was for the last problem. So B is also going to be 83.97 feet. Let's try C. If the car the girls are riding has a central angle of 180 degrees from horizontal when the wheel stops, how high above the pier are the girls? So that would be right here. So how high above the pier would they be? Well, they'll be simply 45 feet, just the height of the radius. So for this one, it'll be 45 feet. And for D, if the car the girls are riding has a central angle of 225 degrees from horizontal when the wheel stops, how high above the pier are the girls? So 225 feet, that'll be right over here. And remember that the central angle, let me put in my radius here. The central angle is the one that starts at our initial point and all the way around. And nonetheless, this makes a 45, 45, 90 special right triangle. If this was 1 unit, then this measure here, because we're talking about height, that's going to be the square root of 2 over 2. But it's not 1 unit, it's 45 feet. So we do 45 times the square root of 2 over 2. Now that's this measure right here. We want to know what this measure is right here. We want to know how high they are above the pier. So if from the horizontal here, the x-axis all the way down here is the length of the radius, that's 45 feet, then all I have to do is subtract out the 45 root 2 over 2 from the 45 feet, and that's going to give me what's left over. So if I did 45 feet, 45 feet is from here all the way down to here. 45 root 2 divided by 2 is from here to here. Subtract 1 from the other, and we have the distance that's right here. So going back to our calculator, I'm going to take 45 times the square root of 2. Don't forget you have to hit that arrow key to bring that over. Divided by 2. And then we're going to hit those double arrows. So the distance from here to here is approximately 31.82 feet. If I take 45, and you could type it in just like this, 45 minus, and as you can see right here, that ANS, don't forget that that ANS stands for the answer. So if I go second answer, so I'm going to take 45 feet, that's this right here, minus the answer, which is 45 root 2 over 2, and hit enter. I come up with approximately 13.18 feet. So D is 13.18 feet. And there you go. This is a very fun problem.